It has been said for ages and ages by the ancient Greeks that Icarus, who flew too close to the sun, tragically fell to the sea and drowned when the heat melted the wax in his wings, was a warning to humanity not to dream the impossible, because doing so will only lead to us falling further. But has humanity ever heeded any warnings? In addition to flying dangerously close to the sun, we dared to touch it. NASA's Parker Solar Probe became the first artificial object to make contact with the sun, succeeding where Icarus failed. Aboard a Delta IV Heavy rocket at Cape Canaveral, humanity launched its first attempt to touch the sun on August 12, 2018, at 3:31 a.m. The Parker Solar Probe represented the culmination of solar exploration concepts that date back to the late 1950s, and NASA realized it for the negligible price of $1.5 billion. Welcome to Z. Let's find out how humanity changed history by making contact with a star. Dr. Eugene Parker, who invented the term freeze and predicted the emergence of the solar wind in 1958, is the source of the name Parker. Dr. Parker attended the 2018 launch, which was also clearly the first time in history for a person to witness a space mission named after him launch, and that too obviously was the first time in history for a person to see a space mission take off. It's been a long time, but fortunately Dr. Parker is still with us, making it the first time NASA named a spacecraft after a living person. Reaching our nearest cosmic neighbor at a speed of around 0.05% of the speed of light, we need to prepare enough sandwiches for at least several thousand years once we leave the solar system Proxima Centauri, with Parker operating at full throttle, but we digress before arriving at our sun. The Parker Space Probe completed the first of 7 planned flybys of Venus, passing through the planet's upper atmosphere and using the planet's gravity to adjust the probe's orbit to make even closer approaches to the sun. While not quite the sun's core, the Parker Space Probe will reach the 4-yard line just outside the sun's end zone at an astounding 3.83 million miles from the sun. Helios 2, which crossed Mercury's orbit in 1976, brought humanity to within just 26.987 million miles to its solar neighbor, or just 30 yards away. What does NASA expect to achieve by placing the Parker Solar Probe quite a distance from the sun? The spacecraft has 4 sensor suites that it will use to research magnetic fields, plasma, energy particles, and create photographs of the solar wind during its 7-year mission. Although solar wind has been known about for decades, we still know very little about it. Our observations of solar wind have brought it within tens of millions of miles of our planet after it has been cooled and mingled with its extraordinarily close passes. Parker will examine how energy and heat are propelled to attain tremendous velocities in the solar corona. Plus, solar energetic particles, or SEPs, are tiny solar projectiles that travel 93 million miles to Earth in just an hour. They can destroy delicate electronics on spacecraft and potentially pose major threats to humans, and Parker may provide an explanation for their origin. Compared to other solar expulsions, SEPs have a distinct mixture of particles, including more of some and fewer of others, such as sulfur. What astronomers refer to as the coronal heating problem is a significant open topic for the Parker Solar Probe. For the first time, astronomers will collect measurements inside the corona itself in an effort to solve one of the greatest cosmic riddles. The sun's surface heats up to 10,000 degrees Fahrenheit, while out in the corona, the temperature soars over 2 million. The sun doesn't have a solid surface, but it does have a photosphere, which is where most of the direct sunlight that strikes Earth comes from. There is also an alpha and critical surface, which marks the end of the sun's atmosphere and the start of the solar wind. In essence, when the sun's gravity and magnetic fields are no longer able to keep solar material close, it leaves the sun and never returns. Knowing exactly where the alpha and critical surface are would dispel estimates that range from 4.3 to 8.6 million miles from the sun's so-called surface. Even before reaching the sun, Parker surprised everyone back in 2019 when it found magnetic zigzag structures in the solar wind. The origin of these has been confirmed to be the solar surface. Now that we are there, the answers are just around the corner. Astronomers want to utilize data from Parker to understand how switchbacks are generated and even why the corona is so much hotter than the solar surface. This announcement from NASA's Science Mission Directorate's Heliophysics Division Director, Nicola Fox, confirmed to the world that Parker had indeed dipped into the Sun's corona on April 28, 2021, during the spacecraft's 8th close approach to the Sun. It took nearly 8 months for NASA to get the data back and analyze energy reactions recorded by Parker during that time, but we now know that it was indeed accomplished. Scientists aim to find out how they line up with solar activity to understand how this activity impacts the atmosphere and, more significantly, solar wind. The spacecraft dipped below and came back above the surface 3 distinct times, revealing that the Alphen critical surface was wrinkled. Parker dug farther deeper and discovered a fake streamer. These brilliant loop-like formations that appear above the Sun's active areas the feed is said to have flown into a storm eyed by NASA. Fast forward to August 2021, and the description fits Parker's experience to a T. The solar conditions quieted, particles slowed, and the number of switchbacks decreased as in the eye of a cosmic hurricane. The creation of a stunning 13-second time-lapse film after taking the first photographs ever from inside the Sun's corona may be the most astonishing component of this historic achievement so far. The coronal streamers that the Parker solar probe sailed through the breathtaking streaks of light from Earth that are visible in pictures of total solar eclipses the photographs of our solar system taken by Parker's wide-field imager from inside the Sun's corona, which show the Milky Way and several planets, including the Earth from the Sun, are even more astounding. This astounding achievement for humanity raises the question, how did we manage to do this? How does it not melt? Did you say the corona reaches millions of degrees Fahrenheit? Middle school students from all over the world might raise their hands to ask their teacher this most straightforward question. Their teacher and NASA would likely respond by explaining that there is a significant distinction between heat and temperature as the corona is thin and has few particles to transfer energy. Yes, the particles are moving quickly and the temperature is high, but very little energy or heat is actually transferred to the spacecraft. NASA compares it to the difference between putting your hand in a hot oven and putting it in a pot of boiling water. Both are not recommended, but neither is the corona's situation. The thermal protection system, which is a layer of carbon composite foam sandwiched between 2 carbon plates, is the spacecraft's heat shield because that is all there is to guard against. What does this mean for the sensitive scientific instruments aboard Parker? The side facing the Sun has a white ceramic coating applied as a plasma spray to reflect heat. There is also a single gallon of deionized water to absorb heat as it goes through the solar arrays and deliver it back into space from the vehicle's radiator, even if the Sun side of the spacecraft reaches 2,500 degrees Fahrenheit. With the Sun's regular 11-year cycle of changes in its magnetic field becoming more active through 2025, the spacecraft will likely enter the corona again during the Parker Solar Probe's next solo flyby in June 2023. As the corona expands, Parker will have a greater chance of staying inside for longer periods of time. Therefore, after our first trip to a star, what do you expect humanity will learn? Please share with us in the comments, and as always, thank you for watching.